Thanks for watching AI Weekly Update from Henry AI Labs. This video is going to cover updates to artificial intelligence in this week up to October 28th. This is going to cover really cool things like Google applying the BERT transformer model to improve Google search, a really cool model from Google using graph neural networks in order to predict olfactory properties of molecules, like learning to smell on these molecule data sets labeled by perfume experts. We're also going to look at NVIDIA's Mellotron project, which is a technique to condition generated speech, text-to-speech, by using rhythm and this kind of thing, conditioning it on songs, and then having the speech have the same kind of rhythm in the generated speech, which is really cool. Then we're going to look at the Natural Language Processing Monthly Newsletter from Sebastian Ruder. We're going to look at things like Microsoft Research's Compositional GAN, which is improving on the generated images with natural language instructions, and a lot of really cool other research and different things that have come out in AI this week. Thanks for watching, and please subscribe to Henry AI Labs for more deep learning and AI videos. This weekly update video will cover a lot of interesting updates to artificial intelligence this week, like Google integrating BERT into search, Google's learning to smell using deep learning and graph neural networks to predict the olfactory or smelling characteristics of molecules, predicting different scents based on molecules, and using these graph convolutional networks to propagate the features of atoms into the entire molecule. Then we'll look at Sebastian Ruder's monthly newsletter, Natural Language Processing News. Sebastian Ruder is an expert in the field, and there are a lot of great things in this newsletter about updates to deep learning and natural language processing. From Microsoft's research blog, we'll look at a compositional GAN model that is able to modify images based on natural language instructions, so a really cool model. Then we'll look at The Batch from Andrew Ng, covering stories like OpenAI's Rubik's Cube, electronic health records advancements, and a lot of other really cool things in AI and deep learning. From Facebook, we'll look at the study on using videos to teach AI about objects, particularly looking at videos and looking at how humans interact with objects to form these hotspots for where robots can think of interacting with these objects. From Stanford's AI Lab blog, we'll look at this article, Answering Complex Open Domain Questions at Scale, a really interesting article and presenting an iterative query refinement system for answering these complex open domain questions. From TechCrunch, and then we'll look at Semantic Scholar, they've expanded their database to cover 175 million papers. There's some really cool things in this, like searching for papers based on ideas like GANs for data augmentation, or looking at related papers from a paper you're already looking at. From NVIDIA, we'll look at the announcement of the Jarvis multimodal SDK. Having models that can leverage visual information to do better things like speaker classification, or speech to text and these kinds of things. Also from NVIDIA, we'll look at the new Data Science PC. This is a really cool system that I've gotten the chance to use myself that has these two Titan RTX GPUs with 24 gigabytes of memory to accelerate data science and deep learning applications as well. Especially you can check out the Data Science PC in tangent with the Rapid software stack to accelerate machine learning data science on tabular data sets. Also from Microsoft's research blog, we're looking at rep points, a technique to improve on the information achieved from the object localization with these points to have a more accurate representation of objects. Also from NVIDIA, we're looking at their description of panoptic segmentation for self-driving cars compared to bounding box segmentation. Then from Berkeley's research lab, we're looking at this article on collaboration with AI systems, particularly when an AI system is now collaborating with human teammates, and it needs to learn to adjust its strategy and have a sense of a model of its teammates in cooperative environments. Also from NVIDIA, we're looking at their Project Mellotron, multi-speaker expressive voice synthesis by conditioning on rhythm, pitch, and global style tokens. We'll see some really cool examples like using the Adele song to condition the rhythm of the generated speech from the text-to-speech model. From NVIDIA, we'll also look at this brain hemorrhage detection study and report on using computer vision to do segmentation as well as detect brain hemorrhages from injuries. From Medium, TensorFlow's Medium blog, we're looking at how to build and deploy TensorFlow JavaScript models with the power of AutoML using this really powerful AutoML Vision Cloud service from GCP. This is how you use it with the TensorFlow JavaScript library. So then we're looking from Google this paper at Unified Text-to-Text Transformer, a massive 750 gigabyte data set, training these models, and one of the new most interesting models for using transfer learning and pre-trained language models. From Weights and Biases, we're looking at this really cool example problem of semantic segmentation from drone images, and some of the applications like agriculture, nature conservation, construction, disaster relief, and we'll go through the repository, some of the different dimensions that they're looking to improve on, and how you can use the Weights and Biases interface to iterate on these different dimensions. From Facebook, we're looking at the slow fast model. This is a really cool video recognition model that's combining image processing at 2 frames per second with 16 frames per second to combine the different kinds of information necessary for video understanding. Also from Facebook, we're looking at improving long-form question answering by compressing search results. This is a really cool technique to improve on how you form knowledge graphs that are useful for question answering. Also from Facebook, we'll look at some of the research that's being presented at the ICCV, International Conference of Computer Vision Conference. Also from DeepMind, we're looking at this approach to the sim-to-real adaptation using a self-supervised contrasted forward dynamics loss. And then from Google, we're looking at the Fréchet audio and video distance, which is a technique to evaluate generative models, because generative models don't have natural metrics like classification accuracy in order to benchmark them against each other. And this is a really cool technique that has been used in images for a while and is now being expanded into audio and video. And Google has provided a really useful implementation on GitHub that it's as easy as just import the metric and then calculate the metric, compared to having to really calculate this metric on your own. One of the eye-opening, catching headlines from the AI news this week is Google's learning to smell, using deep learning to predict olfactory properties of molecules. So this is a really cool application of graph neural networks. So the idea behind learning to smell from Google's paper is that you have these message-passing graph neural networks. So this is best described in 3.1 of their research paper. So basically the idea is that graph neural networks, graph convolutional networks, are, I think, best understood in the context of research paper citations, where the edges are citations between papers, and then the initial features that you use for the paper are like the natural language processing features, things like term frequency, inverse document frequency, TF-IDF, miscellaneous other things to have these initial features. So in this case, the initial features are the some features of the atoms. So all this different chemistry thing that are used to describe atoms, and then they are linked to each other based on their connections in the molecule. So what you would have is you would have this matrix where each of the atoms is described by their features, and then you have this separate matrix which denotes the connections, which is used to form the graph convolutional kernel. So basically the idea is that the features are aggregated from the neighborhood. So this atom right here is connected to this one, and this one. So there'll be some kind of graph convolutional filter that sort of aggregates the features from this neighborhood to form the updated feature at the next layer of the matrix. So after a few layers of the graph convolution, the atoms are flattened into this vector by multiplying the matrix by some n by 1 vector, resulting in this vector that is learning the features for each of the atoms. Going from these original features describing the atoms to aggregating the features from the local neighborhoods, and then resulting in this vector describing each of the atoms. So then you have this fully connected neural network, and it's used to predict these different odor descriptors, which is this idea of learning to smell, learning to predict the odor of a molecule. So definitely a really cool idea. So also really interestingly is the collection of this data set. So they have an expert labeled set of 5,030 molecules from experts with things like perfume materials, which is interesting, and definitely an interesting data set. Uncommon study in deep learning is this, studying learning to smell with deep learning. So definitely a really interesting paper. They describe a lot of interesting things. Also interestingly in this paper is that they compare it with the random forest baseline. I think it's in the research paper. And so they improve over the random forest baseline, but it's not like this massive improvement with the graph neural networks. But I think it's definitely graph neural networks that are probably a little understudied because there hasn't been enough applications. So now we have things like studying social networks, studying citation networks, and studying learning to smell. And I'm sure there's others that I just can't remember on the top of my head. But then also interestingly is you can see the embeddings and how they're embedding similar smells with each other. Microsoft's research blog has presented a really interesting generative adversarial network model based on tell, draw, and repeat, so iteratively constructing the images. So an example they provide in the blog post is you start off with an empty canvas, then you give natural language instructions to the generator, like add a yellow sphere to the center, it adds a yellow sphere, and then you can iteratively construct the image using these natural language instructions. So this is similar to a study in ICLR from MIT, the PizzaGAN, where you have this compositional hierarchy where you can add or remove toppings because the model has the sense of how to compositionally increment the image. So their full paper is titled Tell, Draw, and Repeat, Generating and Modifying Images Based on Continual Linguistic Instructions. They're training their model on these two data sets, Clever and then CoDraw. So Clever is a data set for visual reasoning, asking questions about these things like, are there an equal number of large things in metal spheres? And things like how many objects are either small cylinders or red things. And then this other data set, CoDraw, is a collaborative drawing, is a test bed for grounded goal-driven communication, probably a little closer to the overall idea of the model. So it's definitely an interesting model. This idea of compositionally constructing images is definitely important for artistic applications, things like this, generating images, speech, video, text. Is really cool to be able to have this compositional structure. So the way that this goes is you have the D sub t, which is the encoding for the natural language instruction. So say you give it the instructions in the example, add a purple cube behind it on the right. The language model will decode this into the vector D sub t. This will go into the GRU because you want to have some kind of recurrent unit here that persists the memory, so that say you go add a purple cube behind it on the right, you don't want suddenly the background to say like grass or something. You don't want it to distort the image too much. You want it to have some memory of what it's already generated. So it uses this, and then it uses this conditioning augmentation. This scheme is really similar to a paper called StackGAN, where they have this sort of vector concatenation for the seed vector for the generator. So then the generator produces the image. It compares it to how much it's diverged from the last image to make sure that there's some consistency. And then this is fed into the discriminator part of the GAN framework to train the model. From Google's AI blog is audio and visual quality measurement using Frechet distance. So this technique, the Frechet inception distance, is commonly used for image generating GANs. So for example, the big GAN is able to generate these dogs, cheeseburgers type of images. But to compare something like the big GAN with the DC GAN, progressive GAN, all these different architectures, we need some kind of metric to compare generative models. So unlike classification models like the ImageNet models, where we can just say, oh, this model is better because it has 85% accuracy compared to 78, we don't really have as many, or we don't have at all clearly defined metrics with generative modeling. But recently metrics have come to light, things like the Frechet inception distance for images, and now they're extending this to audio and visual quality in videos. So they're presenting the Frechet distance for videos and the Frechet distance for audio. So the high-level idea of this metric is that you use a pre-trained model to embed the generated images and then compare the embeddings with the large database of previous music or videos, and then you compute this distance based on the mean and covariance of the embeddings of the generated data as well as the original data. So we have these models for audio like the Tachytron 2,
Generative Adversarial Network or Variational Autoencoder.
And then we have some video generation algorithms. So in order to make progress further in these kinds of generative deep learning applications, we need to establish metrics like the Frechet distance in order to compare models. And this also enables for things like neural architecture search, AutoML, because there's some kind of metric to provide signal to the search. Another cool feature of this announcement from Google is the API that they provide in order to compute this distance. So you see, just import this repository, and then just from Frechet video distance, import the video distance as FVD, and then you just calculate the embeddings and just use it with this one line of code. So this is really cool. I remember doing my thesis, and I had to get the inception score for images generated, and doing this myself was quite a headache. So it's definitely cool to see them already implement this and then provide like an API for developers and researchers to use. So they also provide the repository for the audio distance as well. This week of Weekly Update is really lucky to feature Sebastian Reuter's Natural Language Processing News. This is a monthly newsletter on natural language processing news that I really recommend checking out. I am subscribed to it. This is just the interface that they give you on the Reuter.io website. So Natural Language Processing News starts off with a quick overview of what it's going to go over. Things like the ICLR 2020 submissions, Deep Learning in DABA, and the Europe NLP conference. And then things like transformers, a lot of pre-trained language model news, and then a lot of other really cool things that are curated in Sebastian's newsletter. So the first thing is the ICLR 2020 submissions. You can check this out. They've already published these submissions, and you can see all sorts of really cool papers. Also, something that I thought was cool is previously I had recommended doing an Apple F search, but I didn't realize that it's so good at searching this way. So I actually would rather recommend that you search using their toolbar than doing Apple F for the particular research interest that you have. So it goes on to, they already have 2,600 papers. A lot of papers can be submitted to this highly popular machine learning AI conference. Then it talks about deep learning in DABA. Something that I thought was really cool is there's a link to the slides, and you can see the different speakers, and you can see their talks. So you can come to this multitask learning in NLP and the DECA NLP, this talk from Richard Socher at Salesforce, and his presentation on the future of natural language processing. And definitely really interesting just seeing all the slides that are presented at the conference from absolute experts in the field. So then there is this Europe NLP Summit. You can see the full recordings of the talk, which is really cool, on Facebook. There is the session on transformers, panel sessions, and you can see the whole event on Facebook. So then also in the newsletter is a note on the drama with Suraj Raval. Not something that I'm particularly feel like commenting about, but it talks about overall how he's plagiarized this code and he didn't really cite people and he's kind of been doing these shady things, but it's a weird situation overall. So then the newsletter goes on to these resources for understanding how these different language models fit together. You see, so for example, this graph takes you from GPT to GPT-2. The idea is that larger model and more data. And then the defense against GPT-2 is this Grover model. You see from BERT, we have all these cross-modal. Previously in Weekly Update, we looked at VideoBERT. VideoBERT is this cool model where they're aligning language instructions with the video in order to have this joint multimodal model for video and language representation learning. And they just show overall these paths and then descriptions of the paths to sort of help you see how these different language models are related to one another. So this is also a really great resource, Transformers, that describes a lot of the different learning resources. I definitely recommend this one from Yannick Kilcher that describes the overall idea of the transformer and takes you through an example. So then some other cool things, Amazon's Topical Chat dataset, the Code Search Net Challenge is really cool, the dataset released from GitHub, which is code, and it's sort of interesting to think about natural language processing on text and then on code and using the same model. So then some cool tools, we've seen this control model from Salesforce is a controllable language model, really interesting idea. Things like Intel's NLP Architect comes with the quantized version of BERT and a distillation, and then things like articles and blog posts that Sebastian recommends reading, advice to help you get through PhD, Gaussian process tutorial, and miscellaneous other things. So then he recommends these papers. This one, Discovering Neural Wirings, I thought was really interesting, sort of similar to things like differentiable architecture search or DARTs. And then these are the papers he recommends reading, analysis of the reproducibility and neural recommendation approaches, and then a step towards quantifying independently reproducible machine learning research. So a couple of really cool papers, and overall a really great newsletter helping you stay up to date with natural language processing. So most of the blog posts and commentary on the OpenAI solving a Rubik's Cube with a robotic hand, whether it's from Gary Marcus or miscellaneous other people, are the hype about it and that the system is really separately doing the robotic manipulation, vision, and then having the symbolic, the COSIEMBA solver that's actually solving the Rubik's Cube. So this is a paper from DeepMind that is actually looking at the OpenAI sim-to-real transfer problem solution, which OpenAI proposes automatic domain randomization. In this paper from DeepMind, they're looking at self-supervised learning for sim-to-real adaptation for visual robotic manipulation. So the problem that they're looking at is they have this robot that is stacking the cubes on top of each other, trained in simulation. They want it to generalize to reality. So naturally, the same problem OpenAI addresses in their paper, they have to solve the sim-to-real training test distribution gap. And they do this in this case by using this self-supervised contrasted forward dynamics loss compared to where OpenAI does the automatic domain randomization. So you can see their algorithm presented in the paper, contrasted forward dynamics. This is the key idea between the self-supervised loss that they're adding to their loss function. So what they're doing is overall their network has the encoder of the world, and they're going to freeze this weight, and they're going to fine-tune the higher levels of the weight, sort of like transfer learning idea, by predicting whether the pairs belong to the same distribution in the sim-to-real transfer. So you have the different cases of the simulation and the reality. So simultaneously, while it's learning to stack the cubes on top of each other, it's learning to predict the future frames, and it's doing this in a contrastive loss way, meaning it's got one simulation has the future frame, and then it's predicting whether it belongs to the same distribution, same set of reality points as the current one by predicting into the future, and then using the contrastive loss to say, is this a part of this exact environment parameters for this simulation or not? So I hope that explanation wasn't too confusing, but you can definitely check out the paper if you're interested further in this paper, Self-Supervised Sim-to-Real Adaptation for Visual Robotic Manipulation. NVIDIA has presented the Mellotron multi-speaker expressive voice synthesis by conditioning on rhythm, pitch, and global style tokens. So this is building on the Tacotron 2 global style tokens paper. You can check it out. It's style tokens, unsupervised style modeling, control and transfer, and end-to-end speech synthesis. So this is a speech generation model that is able to condition, sort of like how you do things like conditional batch normalization in the StyleGAN. It's able to condition the speech generation model with rhythm and continuous pitch. So they provide different examples. So basically it has the source of the rhythm and the pitch, like this Nicki Minaj song, or like an Adele song, or this other song, and you can hear how the Mellotron tries to sync it up.
You and I have history, or don't you remember? Sure, she's got it all.
So you can hear how the the text-to-speech synthesis has adapted the rhythm from the song into the generated text speech. So it's definitely a cool step forward. I don't think any of these samples are particularly like mind-blowing, but it's definitely an interesting model. Facebook has presented a really interesting model for video understanding, video classification, frequently used in things like human activity, action classification in these video datasets, like DeepMind Kinetics, the Charades dataset, or the AVA dataset. So this model is called SlowFast, and the idea behind it is really intuitive. It's a cool model, easy to understand. So basically, if you have a 1 second of video data, usually it's recorded at 30 frames per second. So you take apart the second of video, and you have 30 images that make up the 1 second of video. So if you have ever taken apart a video like this, you know that the frames don't change much from, say, 28 to 29 to 30. So basically the idea behind SlowFast is that if you're looking to detect really things that are really fast changing motion, like clapping or waving or quick gestures, you might want to actually look at the images in the video at this kind of rate of 30 frames per second. But in their model, they look at it at 16 frames per second. So what they're doing is they're combining the fast model that's looking at the data at 16 frames per second with the slow model that's looking at it at 2 frames per second, because 2 frames per second is probably enough to detect most of the major ideas in the video. So in their research paper, SlowFast Networks for Video Recognition, they describe their model for combining the 2 frames per second model with the 16 frames per second model, and they show you the architecture that they use with the ResNet layers and how they combine the slow pathway and the fast pathway in order to do tasks like video action recognition. So some of the data sets they tested this on are the DeepMind Kinetics dataset, where they have 650,000 video clips that cover 700 human action classes. The Charades dataset from the Allen Institute of Artificial Intelligence. This is a really interesting dataset that has the paired third-person and first-person videos for the same action. And then this AVA dataset, 80 atomic visual actions in 430 15-minute movie clips. So it's different for having 1.62 million action labels. So a bigger dataset, really interesting stuff, and a really interesting model that is very intuitive. Is probably the best part about this model. Is the idea is really easy to understand. TechCrunch has reported on the recent expansion of Allen Institute of Artificial Intelligence's Semantic Scholar platform to cover 175 million plus papers in all scientific disciplines using natural language processing models in order to sort through these papers and answer relevant queries. So something really cool is I thought it would be fun just to go to my paper and look at some of the papers that it has denoted are related papers. So already you can see this is a really cool interface. Reading the paper, seeing access to all the figures, the citations, the references in the paper, and then you can, this is kind of the new feature that I think is really cool, is searching for related papers. So a lot of doing research and surveying the literature is trying to find out, has someone already tested this algorithm, what is similar to this algorithm, and so they're not always just cited by each other. So sometimes you have to really dig deep into Google Scholar, Archive, these kinds of things to find these papers. So the Allen Institute and their Semantic Scholar platform are improving their ability to recommend papers based on the current paper that you're looking at. So another cool thing that it can do is if you search queries about research papers, it does a really good job of answering your query by recommending papers. So you see data augmentation with balancing GAN, synthetic data augmentation for liver lesion classification, a lot of cool things, a really, really cool application, the Semantic Scholar, using natural language processing to sort through the millions of scientific papers and help you with your research, because searching for relevant literature can actually be sort of a headache. Facebook's AI Research Lab presents a really interesting pipeline for improving long-form question answering by compressing search results. So this is one of these great blog posts from Facebook's AI Research Lab that comes with a little animation of the idea. So you have a question like, what is Albert Einstein famous for? And the question answering system has a set of web documents, and it's going to construct a knowledge graph that's going to help it reduce the amount of text it has to process by nearly 30x, from 30,000 words to 10,000 words. So the idea of this algorithm is it uses things like co-reference resolution in order to extract the relationships from the documents and then construct these kinds of knowledge graphs. So then interestingly is this compression with this linearization which is used to feed the sequence-to-sequence model. So the Albert Einstein subject, the theory of relativity, and then the different pathways published, developed, and then the object of the thing. So they have this technique for constructing these data sets. NVIDIA's announced the Data Science PC, and I was really lucky to actually get to test this out. I've written 2 articles testing out miscellaneous things using the Data Science PC. This is an image of the Data Science PC. So you see it has these 2 Titan RTX GPUs, each with 24 gigabytes of memory, and it's got the NVLink. It's a really, really powerful system, really cool. So in this article, you can see an example of classifying video frames, and this is an example of feature engineering with Rapids. So the Data Science PC is really optimized. It's great for data science, things like Rapids on tabular data. This workflow shows the acceleration using the Data Science PC compared to a regular system on this end-to-end New York City taxi data. So you can see overall there's a lot of really interesting things with the Data Science PC and the collaboration with Rapids. So Rapids is things like the CUDF. This is like the GPU equivalent of Pandas doing the feature engineering, transforming your data, and then the CUML, which is implementations of machine learning algorithms like XGBoost, K-means, dbScan, and miscellaneous other algorithms that you can test with the CUML and get a rapid acceleration by using it on GPUs compared to CPUs. And then you have CUGraph, which is the graph algorithms on the GPUs. So it's a lot of really cool things. You can get it from the different PC builders. I got mine from Digital Storm. You can also check out Maingear and Puget Systems building these really cool data science PCs. Stanford's AI Lab has posted a really interesting article discussing answering complex open domain questions at scale. So the article begins by comparing open domain question answering with closed domain question answering. So closed domain, you might be given this Wikipedia article and you know that the answer is contained in the given text, and so you're looking for the answer to answer the question. Whereas open domain is sort of like you're looking through the whole internet, trying to find some answer to some question, like who was the first to demonstrate that GPS could be used to detect seismic waves. It would be easier to say Dr. Larson if you've just been given this one document to find the answer in, compared to searching the entire web. So the technique presented in this article is to have an iterative open domain question answering system that can take in a query, and then it can search for information on it, and then it can propose a refined query. So some of these questions that it's asking, it might be like deciding that it's not quite specific enough, the initial query. So it wants to iteratively build on the query based on the knowledge that it's received so far in order to refine what it thinks the answer is and refine how it's searching for information in this massive sea of information, web documents, miscellaneous things. So definitely a really interesting system. The Stanford article also points to a really interesting demo from the Allen Institute of Artificial Intelligence to communicate some of these ideas of natural language processing. So this first example is an example of question answering, a model trained on the Stanford Squad dataset. You give it this passage and then you ask it questions like who is Penke advised by, you run it, and then it'll find the answer, Professor Christopher Manning. So you can enter miscellaneous passages that you want, different questions to see what the model comes up with the passage you've given it, arbitrary text. And then you can also just sort of get a sense of these different things like squad argument finding, counting, argmax, max, arithmetic, co-reference combinations. It's definitely cool to see these different kinds of challenges. And I think just going through this will help you get a better sense of the challenges of question answering, the different ways of looking at the question answering problems. One of the coolest updates to AI this week is a blog post from Google detailing how they're using BERT to improve Google search. So this blog post describes how a lot of the queries that come to Google they've never seen before, and how a lot of people put their searches with keywordese typing strings because they don't think that the Google search would understand the query if they typed it in how you would naturally ask a question. So they're describing how by using BERT in search, they're able to answer these queries with more natural prompts. So things like 2019 Brazil traveler to USA need a visa. You see the before where it takes you compared to after. Improving search with BERT is answering your question in the in the subtext of the link it's sending you to. So there's a lot of other examples of different queries that have been improved by applying BERT to search, and definitely really cool to see the improvement of search, information retrieval using these natural language processing models and transformers. Currently underway is the ICCV International Conference of Computer Vision Conference, which is a huge conference in computer vision, and we're likely to see all sorts of new, interesting updates to computer vision, interesting papers presented, and announcements like the Best Paper Award. So obviously a participant, this is some of the Facebook research being presented at ICCV. This is a really long list of papers. Some of the things that I thought was most interesting, in the last weekly update, we looked at this drop an octave, reducing the spatial redundancy in convolutional neural networks with the octave convolution. Definitely a really interesting idea for these high-low frequency convolutional filters and the CNNs. And then a paper that I think is really interesting, not like a brand new paper, but is being presented at this conference, is exploring randomly wired neural networks for image recognition. I really recommend checking out this paper. It's a really interesting idea. So you can go through this list of the Facebook research presented at ICCV. Definitely a lot of cool stuff coming out with ICCV. Facebook has presented a really interesting model for using videos to teach AIs about objects, and particularly how to interact with them based on watching how humans interact them. So the paper is called Grounded Human Object Interaction Hotspots from Video. So you see examples like turning pages and how the humans interact with the book, and then the interaction hotspots that are extracted based on the videos, and observing how the how the human manipulates the book to turn the pages. It holds this and it flips the pages this way in this case, and it produces these kinds of maps to help AI learn about how to interact with objects. From TensorFlow's Medium blog is build and deploy TensorFlow.js models with the power of AutoML. So Google's AutoML platform, you can check out their tutorial on Google Cloud, their Edge TensorFlow.js with the AutoML Vision Edge. So what this AutoML framework is it's a neural architecture search platform that is optimizing for a combination of accuracy, model size, and then latency or inference speed. So basically Google's Cloud AutoML service is abstracting away a ton of complicated ideas behind designing optimal neural network architectures. In this case particularly, they're showing you about image. So you see how easy it is to adapt the AutoML framework into the TensorFlow JavaScript library in this code. So you import the scripts for the TensorFlow models, and then you just get your image from the HTML, and then in the JavaScript you get the image, and then you really just, in this one line of code, you just estimate the single pose in the image, and you use the AutoML framework to classify this image. And I think in this case it's actually doing pose estimation, so it's a little more complicated of a model. So it's definitely cool to see the Cloud AutoML Vision integrated with TensorFlow JavaScript, making it more accessible for web developers to use deep learning, and especially AutoML is a particularly powerful framework that's able to really optimize the accuracy, latency, and storage cost. Google has published a new transformer model for transfer learning, a pre-trained language model, in their paper Exploring the Limits of Transfer Learning with a Unified Text-to-Text Transformer, and you can get the pre-trained model from their repository Google Research/Text-to-Text Transformer. So probably the most interesting characteristic of this idea is this idea of aligning all these natural language processing tasks like summarization, machine translation, question answering, text classification, all into this same text-to-text transformer input framework. So also probably most interestingly is the data set that they use to train this model, the Colossal Clean Crawled Corpus. So they describe some of the techniques they use to clean the web extracted text, and overall they result in a data set of about 750 gigabytes. So it's an enormous data set. They report a lot of state-of-the-art results using this model, so it's probably one of the best models to consider for transfer learning with natural language processing. NVIDIA's announced the NVIDIA Jarvis multimodal SDK. This is a really interesting system for combining, this term multimodal describes combining vision, speech, and other kinds of processing systems like natural language processing into the same system. So it describes some applications like doing gaze estimation and speech detection at the same time in this multimodal application. Definitely really cool to see this SDK and the future advancements of these kinds of models that can do processing image data and speech data simultaneously. NVIDIA has presented a really interesting study from researchers at UC Berkeley and UCSF School of Medicine on detecting hemorrhages from CT scans. So, have a head injury and you want to detect whether there's bleeding inside the brain, and so use these CT scans in order to produce images like this, and then you would usually have an expert radiologist. But now we're looking at using deep learning systems to not only classify the hemorrhages as is there a hemorrhage or not a hemorrhage, but also to produce these semantic segmentation masks so that they can measure the size of the thing, the bleeding, and then compute these miscellaneous other characteristics about the about the damage. So their system is trained on, it shows here, 4,000 head CT scans, which is sort of interesting. This case of 4,000, how much data is this? But they're seeing the volume of medical imaging studies on the rise and having more and more data sets, which is really interesting. And then they talk about how important it is to have fast inference and using the NVIDIA GPUs for inference. So it's a really interesting model. The idea also of doing the patch FCN and the idea of splitting the full image into these different patches to perform the segmentation on. NVIDIA published this article describing panoptic segmentation and how it's different from segmenting the world using bounding boxes. So you see here how they have the more detailed pixel map of the different objects compared to the bounding box. And they describe how this kind of segmentation is more useful for tracking different objects, following the object across the frames, and then other things relevant to self-driving cars. So you can see the video that talks about this more. They describe how they're able to use a single deep neural network with an inference time of 5 milliseconds with the embedded NVIDIA Drive AGX platform in order to do this kind of model prediction. Also from Microsoft's research blog is RET-Points, detect objects with greater accuracy through flexible and adaptive object modeling. So the idea here is that typically object localization models put these bounding boxes over things like the maybe person riding skateboard might be the label of this image. But the idea behind RET-Points is that the bounding box is really noisy, and it doesn't even make sense for these kinds of objects to be putting them in these kinds of boxes that are priors from the researchers and developers. So rather what we want to do is put these points of interest, sort of like the key point detection, onto the model rather than the bounding box. So you use the bounding box to initially find where the object might be, and then you refine it with the representative points. So it's definitely a cool model. You see some of the results on tennis players, and how they're able to get a more accurate representation of the tennis player with the key points compared to a bounding box. So it's similar to another paper we're going to look in the weekly update, where NVIDIA is doing this kind of strategy for object tracking for the self-driving cars. So it's definitely interesting to see them moving away from the bounding boxes into the more precise representative points or key points, whatever you want to call this. Berkeley's AI Research Lab has posted a really interesting article about collaborating with humans requires understanding them. So this article talks about how when models train the OpenAI 5 agents playing these games are very cooperative and they behave optimally, but they don't really have a sense of the human player. So when the AI agents are playing alongside human players as well, the human players are less likely to do selfless things like sacrifice themselves or other miscellaneous characteristics about the game that that they expect them to be. The AI agents expect their teammates to be perfectly selfless like they are because this is the optimal strategy. So the idea in this article talks a lot about how AI agents and humans can collaborate and learning to be collaborative and having a sense of your collaborator. So there are a lot of examples in this toy game where you need to collaborate to get the onions and put them on the plate. And then there's miscellaneous other things like where you can shortcut the game. I think it's described up top, where you can shortcut the game by sort of standing here and then having the partner pass you the onions. But if the partner doesn't really understand the strategy and just keeps doing this, then the AI agent is wasting their time. So this article goes through a lot of different ideas relating to cooperative play, and a lot of cool ideas. Definitely worth checking out this article. Weights and Biases presented a really cool benchmark problem to play with, aerial segmentation benchmark with drone deploy. So what this is, these are aerial drone images, and you're segmenting them with semantic segmentation from the drone images. So in this description, they provide some applications for this, monitoring crops, tracking wildlife populations and ecosystem change, and then monitoring safety and progress in construction and disaster relief. So you can come to the GitHub repository, drone deploy, DDML segmentation benchmark. So basically they have the starter code for doing this in Keras or FastAI, segmenting the drone aerial images into these kinds of semantic maps. And they present some different dimensions to improve on. So they present the data augmentation, the hyperparameters, post-processing for inference speedups, chip size, I'm not so sure about that, model architecture, designing the different models that are used to segment the images, and then this elevation tiles that aren't used. So you come into the Keras code and you see how they use the weights and biases into the Keras frame, how seamlessly this is integrated. You just import weights and biases from weightsandbiases.keras, you have the callback, and then you just put the callback onto the fit generator. Well, first you configure it, and then you just put it onto the fit function here. So it's definitely a cool framework, weights and biases. This is a cool problem, drone deploy, semantic segmentation, and showing you how you use the weights and biases in order to search for different configurations of these dimensions of data augmentation, hyperparameters, and things like model architecture. This week's edition of The Batch from DeepLearning.ai begins with a note from Andrew Ng describing how many of the common pitfalls of designing machine learning systems aren't well understood compared to traditional software engineering and understanding software engineering workflows, and how that in the future the newsletter will be focused more and more about understanding the common pitfalls of training machine learning models. So the first article is about the OpenAI Rubik's Cube solver, criticism about using the Cosciamba algorithm, different details of this algorithms such as how the model spent an equivalent of 13,000 years learning how to control a cube, and then miscellaneous things like the automatic domain randomization, applying to the physics in the simulation like the cube size and the mass of the cube, and then details like the Shadow Robot Company, which helped to build the physical hand, and a lot of other interesting ideas about the Rubik's Cube solver. And then there are these links to different YouTube videos showing these other ways robots solve Rubik's Cubes. They're not the same at all. It's not like a robot hand manipulating the cube. It's like kind of these discs that just like spin it until it's finished in like half a second. Definitely really funny videos to check out. So the next post from DeepLearning.ai is public access private faces, and this lawsuit being filed against Facebook from Illinois about the Biometric Information Privacy Act and using these faces for their facial recognition, photo tagging that they haven't really been given permission to use. Following this is cracking open doctor's notes with weak supervision. So this idea is that these doctor's notes are like handwritten notes. They're not formally put into an electronic health record, but you want to be able to transcribe the notes into the health records so that you can predict things and learn about electronic health records. So it describes a framework, the Snorkel framework, for making use of this labeled data, this weakly labeled data, and doing it to unlock new capabilities in electronic healthcare analysis. So the next idea is robot tanks on the march. This idea of using autonomous weapons, and then the batch talks about how they don't support this kind of idea. The next article is new materials courtesy of Bayes. This is a cool idea, kind of like drug discovery, how the deep neural networks are trying to predict materials and compositions of materials that might be able to perform certain tasks, and it saves them with a lot of the trial and error that is involved with material science and designing new materials. Following this is a description about how neural networks generalize, a study from DeepMind where they are given a set of objects and then generalizing from objects that they've been trained on to never before seen objects, and an interesting sort of result where it's 91% successful in lifting novel objects, but only 50% successful at putting novel objects, like put the object on top of the red square or something like that. So it's definitely interesting. Neural network generalization is probably one of the most interesting characteristics of neural networks. It's kind of the whole idea. And this is a really interesting article describing a study on generalization. Thanks for watching this edition of AI Weekly Update from Henry AI Labs. You can find timestamps linking to the different blog posts, research papers, and miscellaneous other things covered in the video in the description, or in the comment under the description. And then in the description you can see the links to the different articles and miscellaneous things. So thanks for watching, and please subscribe to Henry AI Labs for more deep learning and AI videos.